In this video, we are going to look at the CVP analysis when we have a sales mix, which means when we are selling more than just one product. The example we are going to use here is example number 3 on your worksheet. And it states that we manufacture two sizes of windows, F and M, and the ratio 5:3. Now what that means is that for every 5 F windows, we make 3 M windows. F has a selling price of $150, M has a selling price of $200. The variable cost of F is $75, and the variable cost of M is $90. The fixed costs are $352,500. What it wants us to find and compute, it wants us to compute the calculated weighted average contribution margin, the break-even in packages, and the number of units of each product that would be sold at the break-even point. So in doing this problem, you have to have a chart. And in your chart, you need to list the sales price. You need to know what that variable cost is. And those are given to us in the problem. So for F, it tells us that they sell for $150, M sells for $200. F's variable cost is $75 and M's is $90. Well, we know in our CVP analysis that sales minus variable cost equals our contribution margin. So the next part of this chart is going to be the contribution margin. So I'm going to take $150 minus $75, and that'll give me $75. I'll take $200 minus $90, and that gives me $110. So that is my contribution margin for F and for M. With a sales mix, which is when we sell 2 or more products, we have to look at what ratio we're selling them at. And so in the CVP analysis for a problem with a sales mix, you would look at that sales mix. In this case, we produce 5 of F windows for every 3 of the M windows. So it's a 5:3 sales mix. We will be looking at that ratio. So the next thing we do is we take the contribution margin, we multiply it by the sales mix, and what that's going to give us when we look at the total is that weighted average contribution margin. So when we take 75 and we multiply that by 5, we get 375. When we take 110, multiply that by 3, we get 330. And if we add those together, that is 705. So that is really what we're looking for in that weighted average contribution margin, is that 705 there. The next thing that we look at that it wants us to find is that break even in packages. So these are the total packages, and one package would contain 5 F windows and 3 M windows is what a package would contain. And so in doing that, we would need to know what the fixed cost was divided by that weighted average contribution margin. So in this particular case, what we have is a fixed cost of $352,500. We have this weighted average contribution margin of 705 that we just found. When we do the math, we find that we need 500 packages. So that's our weighted average break-even point in packages. The other one it wanted was the break-even in the individual unit. So it wants the break-even for F and the break-even for M. And what we would do is we would take the number of packages, and then we would multiply that by whatever that sales mix number is. So for F, what we would do is we would take the 500 packages, we would multiply it by 5 in each package, so that means we would have 2,500 F windows. For M, we would take the 500, multiply that by the 3 because that was the sales mix number for M, and so we would need to produce 1500 M windows. So this is what we would be looking at as far as the individual units that we would have to produce in the sales mix. You will have a problem like this on your test, so you need to make sure that you understand how the chart needs to be set up, and you also understand these equations. They do go back to the ones that we have been working up to this point. So it's very, very important that you understand what these equations are that you have out there to be able to work this particular problem, which is that sales mix problem.